Example 3. Listed below are the number of absences and the final class grade for 4 randomly selected students in a certain class. The linear correlation coefficient R has been determined to be negative 0.947. We're going to assume this is a strong enough linear correlation. Since my sample is only 4, usually you need really high numbers, and we'd have to check if 0.947 is actually high enough. But we're going to go ahead and create a regression model to predict the final class grade of a student who has 4 absences. Notice our table of students with 2, none, 8, or 5 absences, but nobody listed has 4 absences. So the first thing I need to do is list the number of absences, and that's my X column. So I copied the 2, 0, 8, and 5 down and totaled them. Next, I need to make a column for the final class grade, which is my Y column, and I'm going to copy the 96 through 82 number down, and then I'm going to total those numbers. Now I'm going to make my XY column, so multiply 2 and 96, 0 and 84, 8 and 75, 5 and 82, and then total the 4 numbers I've just calculated, 1,202. Next I need to make my X squared column, so 2 squared is 4, well 0 squared is 0, 8 squared is 64, and 5 squared is 25. Totaling the column, I get 93. And last is my Y squared column. This one's going to get big. 96 squared, 9,216. 84 squared, 7,056. 75 squared, 82 squared. And as I total these large numbers, I get 28,621. I'd kind of run out of room. That's why I'm writing it off to the side. But I've noticed that I've got 4 items. Partially, I was told that it was a collection of 4 students. Secondly, we totaled up how many sets of data we have. And we're ready to find A. So A's formula starts off with the sum of Y. So we'll start off with the 337 number times the X squared sum, which is the 93 number, minus, now we want just the sum of X's, so 15, and we multiply with the sum of XY, which is the 1,202 number. For my denominator, I start off with N, which we said was 4. I multiply with the sum of X's squared, which is the 93, and I always start to notice that pattern, how it's like that 93 copies straight down. And if you remember, it's the same thing that when I go to subtract the X, the sum of X's quantity squared, it felt like the 15 copied straight down, except for this time it's squared. So I calculate the numerator to be 13,311. Wow! That might sound really scary and huge. The denominator is 147, which actually might feel big compared to some numbers. And as I divide these, I get 90.5510. We haven't seen numbers this large, but it's completely appropriate. Finding B. The formula starts off with N, so 4. The sum of XY, which is the 1,202, and the formula is minus, and then the top starts to look the same, right? It's the sum of X, but then it gets multiplied with the sum of Y, which is the 337 number, all over 147, because remember, it's the same denominator. So my fraction is negative 247. It's completely fine to have a negative. It just means we have a negative correlation that as X increases, Y decreases. And I calculate negative 1.68, etc. I'm now ready to find my linear regression model of the form y equals a plus bx. And y equals, I come over to a, I'm going to go ahead, and even though the directions, oh, it did say use 3 digits during the calculations, that means I need to use the 551, and it doesn't round up. So I'm going to have 90.551 plus B. Again, I'm rounding 3 digits after the decimal, so I will actually have negative 0.1680. Had I paid attention, I would have put minus in my formula. Don't forget the X. Everyone forgets the X. So we were finding the results for a person who had 4 absences. And so that means we're letting X equal 4. I come to my model, and where X is, I enter a 4, and I calculate 83.831, rounding 1 digit after the decimal for my answer, 83.8. Now remember, the last piece I mentioned is always, does your answer make sense? So if we're looking at 4 absences, it's in between 2 and 5. I would expect my answer to be in between 96 and 82. You'll notice the numbers were decreasing. I kind of already mentioned that we have this negative slope. So as our input goes up, our output goes down. Now, 83 is in between these two numbers and closer to the 82. So I do feel pretty confident that 4 absences would result in a class grade of 83.8 if there was a direct correlation between class grade and number of absences. So I feel like I've probably got this correct.